Hello, this is High Paid Hobo. This video is a quick demonstration of using a desktop CNC milling machine to make a resin casting mould from machinable wax. The machine I'm using is a Roland SRM-20. The goal is to make 3 moulds for parts of a tool carrier I designed for a Dremel drill press. So this is the empty machine. You'll see the base plate's not standard. I'll tell you a bit more about that later. It's a magnetic base plate that I made. This is the wax in its cast state. That's the casting box for the wax, and that's the shrinkage you get when you're casting. It's quite large, as you can see. This is the base plate. I'll talk a bit more about that later, but this is what I put the wax on for machining. So there's the wax on the base plate. To connect the base plate to the wax, we weld it using a soft wax and a soldering iron that's got good temperature control. It's important to keep the chips away from this surface because if you have anything stuck under there, it'll cause misalignment later on and bad machining. The workplace should be firm with no wobbling. So here's a time lapse of getting the first shied machine. This has ultimately become the base of our mould. It's important to get it nice and flat. Next, we're going to put some dowel holes in the base plate. It's important to dowel this so you can align it onto the base plate. Relying just on welding it is not good enough for final machining. So I get another base plate and I put the dowels in it and I turn over and snug it down onto the machine block. After this, what we're going to have to do is take the original side base plate off. Now, it wasn't doweled on, it was just welded on there because when you originally cast the wax, there was no dowel holes and it's not possible to machine accurately to get them. So this bit of the video is showing how this piece is removed because it didn't show how it was put on there in the first place. So I just leave the old one off. The wax that I've used here is a soft wax, it's not a machinable wax, it's a different kind of wax entirely. You want to get rid of the red wax there because if you get that mixed in with your machinable wax and then remelt it, it's a contaminant and it will cause soft spots in the machinable wax. So whilst I'm scraping the weldings off this block, I want to vacuum them out of the machine. I might add a vacuum cleaner as a really nice thing to have around when you're doing this type of work. Now we surf the second side of the block, which is ultimately our zero height for the tool. Since we've finished servicing, I need to change the tool for something that's more appropriate to the size of the machining I'm doing. So I'm changing down here from a 6mm down to a 3.175 or 1/8 tool because that'll allow me to mill some of the surface features that I need to. I now need to set the zero height of the tool and also the free length of the tool. The little piece of paper here is essentially a gauge that I use. It's 27mm long on this tool to allow me to set the free height. If you don't do this, you can end up crashing the tool into the block or the tool holder into the block. The other thing to be mindful of is the ultimate cutting depth of the machine you're using. With this tool, for instance, if I have it set at this height, it will never be able to machine right to the bottom of the base. Sometimes that's a good thing, sometimes it's a bad thing, but it shouldn't be a surprise. So you need to make sure you know what ultimate depth you need to achieve in the milling. So for this next bit, I'm actually segmenting the base. Roughing, and this is a roughing cut called a waterline pattern, so it's going around and around the vertical surfaces. For this particular piece of moulding, I'm actually creating 3 moulds out of the one block, and to try and control effects from internal stress in the block, I'm segmenting it into small blocks as the first cut. And the other advantage of doing the vertical surfaces of the mould first is that it makes it easier to avoid tool crashes when you're doing the later surfaces. So here I'm cleaning out the shavings. I'm going to melt these down. I'm actually putting them in a little strain, and then I just do a little check on the cut to make sure that it's nice and flat. Now I'm starting the second cut, which is still a waterline, but I'm now roughing the internals of the mould. So I'm not going around the outside anymore. That cut's finished. I cut the internals in a rough cut, leaving a little bit of clearance for later finishing. So that's what the waterline rough cut looks like. So now I'm doing an XY finishing cut. This takes the wax to the final height for the mould for this size of tool. That doesn't mean all the details done, because this particular mould is going to require some engraving later on because of some of the fine details on it. Interesting to note the shavings that are occurring here. That's an issue to do with the waterline cut being rough and then doing an XY cut as a finish. There's always a little bit of full height cut on the tool there if you do it that way, so you've got to be a little bit careful about how you use that tool. So coming up next is the Y part of the XY cut. So we're just doing the other axis. This is not 100% necessary, but it does give you a little finer surface finish at the end of the day. There's a bit of a trade-off between how many hours you want to spend machining and what level of surface finish you get. This machining is done, I think, at a 1mm interval, which is fairly coarse. So doing flat surfaces in an XY, 3mm tool on a 1mm interval will give a reasonable finish on the horizontal surfaces, but pretty average finish on anything that's sloping. So this part of the operation is with an engraving tool which has a 0.2mm diameter at the end. This is because this mould has a serration on this surface, and you can't do it with a coarser tool, so you have to engrave it. Very slow process. You sort of want to design your mould so you don't have to do a lot of these types of operations. This is engraving tool's 0.2mm at the end with a 10-degree slope on the edges. That also limits you on how deep you can get with the tool. In the next section, I'm going to use an even finer engraving tool to go deep in another part of the mould, which is the matching portion of that serration. I didn't just use the one tool all the way, because as the tool gets finer and finer, you have to machine more and more slowly, so it gets very time consuming to use very fine tools on these moulds. So, the total time for one of these machining is about an hour and a half. So here's the final result of the machining. It's actually 3 moulds in one block that I'm going to cut up with a saw, separate the parts, and then use to mould the item, which is actually our tool holder. So it'll look like that.